So we'll go ahead and find the possible rational roots. The rational root theorem tells us that any p's would divide into 25 evenly. So we have plus or minus 1, plus or minus 5, or plus or minus 25. And any q's would divide into the 3 evenly, the highest degree term's coefficient. So plus or minus 1, or plus or minus 3. And then we make a ratio out of those. So possible fractions made out of those. And I'll just put the plus or minus at the beginning here like your WebAssign problem asks. So plus or minus all the p's over all the q's. So first I'll take the 1 for the p. So 1 over 1, that's just 1. Or 1 over 3. And now I'll go to the 5. So 5 over 1, that's just 5. Or 5 over 3. And then the 25. So 25 over 1. Or 25 over 3. So that's all the possible rational roots for this polynomial. Now you would look at the graph of the polynomial. So you put that in your graphing calculator, and you get something that looks like this. So you have your 1 here and 2 here. So on the graph, it looks like I have 2 roots. It looks like I have 1 for a root and something between 1 and 2. So I look at my list. I'm going to try the 1. And now I need something between 1 and 2. So between 1 and 2 would be 5/3. So I'll go ahead and use those two numbers with synthetic division. If I get a 0 for the remainder, then I have found the 2 rational roots. So let's go ahead and try some synthetic division here. So 1 first, 3, negative 8, 20, negative 40, 25. So start with a 0. 1 times 3 is 3. Add that, we get negative 5. 1 times negative 5 is negative 5. Add and get 15. 1 times 15 is 15. Negative 40 plus 15 is 25. Negative 25, and negative 25 times 1 is negative 25. So sure enough, my remainder is 0, meaning that 1 is a root. Okay, let's see if the 5/3 is. So put 5/3 in my box. And you can continue on now. Just ignore the 0 on the end and use the polynomial represented by 3, negative 5, 15, and 25. So start with a 0. We get 3. 5/3 times 3 is 5. We add and get 0. 5/3 times 0 is 0. 15 plus 0 is 15. 5/3 times 15 is 25, and that adds to 0, so our remainder is 0. So we have a second root here. We have a root of 1 and a root of 5/3.